environments webinar. We are going to be discussing how utility incentive programs can affect equipment upgrades. This session will be led by Jim Stark. He's our Manager of Engineering and Construction in Electronic Environments, and he'll be outlining some best practices related to maintaining, upgrading, or replacing critical infrastructure equipment. Some of the decisions that our customers have faced over the years, we'll be able to borrow from Jim's experience. We also have participation from 3 utility companies today, from NSTAR, from National Grid, and from Con Edison, and they'll be discussing utility incentive programs that they provide to give you a little bit more information on how those incentives might shape those decisions, whether you want to upgrade some equipment or even replace that equipment. So we hope it's very valuable. We will move on to introducing our speakers. I'll ask everyone just to take a quick moment and introduce yourself and give a little bit of background on yourself and your organization. If we could start with Jim.
Yeah, hi, so this is Jim Stark. As John said, I manage the engineering and construction for EEC. So been at this for a little over 20 years, and you know, we've gained pretty good insight into how data center facilities operate, you know, what the vulnerabilities are, and I guess kind of what the equipment replacement cycle is. So excited to get going with the presentation.
Great. Fran?
Fran Boucher with National Grid. I'm the Data Center Initiative Manager. I've been doing this for about 5 years and actually ran data centers for State Street Bank for 10 years, and I'm very passionate about this and would love to help you.
Great. Welcome. Amelia?
Hi, everyone. My name is Amelia Axtell, and I work for Lockheed Martin, and we deploy the Con Edison Data Center Energy Efficiency Program in the New York City area.
Great. And Patrick?
Good morning. This is Patrick McDonald with NSTAR Electric, now part of Northeast Utilities. And as an account executive, I work directly with our largest data center clients, and I also work with corporate standalone data centers as well. So if you're a large company that has its own data center, I work with those folks as well.
Terrific. Great. Well, thank you all. The first section, as we mentioned, will be from Jim Stark, and we'll be going through some best practices regarding the life cycle of equipment and looking at upgrading and replacing equipment. And Jim, I'll turn it over to you.
All right, great. Well, I want to thank everybody for joining us this morning. So at EEC, we've been maintaining data center critical infrastructure for about 28 years now. And over that period of time, we've collected data on equipment longevity, the factors which can contribute to equipment failure. I think because most data center grade equipment is designed to last for a decade or more, there can be a tendency to take its reliable operation for granted. But the truth is that UPS and cooling equipment does become less reliable over time. This equipment is built to run 7x24, and I'd say we've probably seen systems in operation for 10, 20, you know, maybe even beyond 20 years. But parts availability can become tough, and parts do have a limited life expectancy. You know, 7x24 operations do take a toll on this equipment. Another factor that can contribute is if the equipment's not being maintained properly. So as equipment ages, the cost to maintain and repair it also increases. Parts for old equipment can become difficult to source, which will extend the mean time to repair. More frequent repairs also become more costly, and they will have an impact on data center uptime. With regard to efficiency, you know, there's been great advances in technology over the past few years, and it's had a dramatic effect on equipment efficiencies. So, for instance, UPS systems are running, or newer ones, are running much more efficiently than their predecessors. And many of these systems now include econo modes, which allow the UPS to run in a bypass mode under a normal operation and then switch to online mode if there's a power fluctuation. The introduction of, let's say, variable speed fan motor drives, EEC fan motors, and digital scroll compressors have all resulted in increased efficiencies for the cooling equipment as well. Okay, John, next slide.
It's just hung up for a second. Hold on.
So how do you know? Yeah. So how do you know when your equipment should be replaced? I mean, this can vary depending on a number of factors: the type of the system, the frequency of the maintenance, and the operating conditions. Typical parts failures in UPS systems would include the batteries, the capacitors, and the fans. With crack units, compressors, contactors, and fan motors are items that are typically in need of replacement or repair as time goes on. I'd say units in service for 10 to 15 years will likely require some, if not all, of these parts replacements. For instance, capacitors typically have a 7-year life expectancy. This can vary depending on the operating conditions as well, whether it's highly loaded or what the temperature is in the environment that it's in. Another large item for us as equipment ages is circuit boards, because these can become difficult to source for equipment that's beyond 10 years of age. So if a UPS or a crack unit in your facility has been discontinued by the manufacturer, this is even a larger concern, presents additional challenges and vulnerabilities. The parts availability will become a problem, and this is obviously going to extend repair times if there were a failure in the circuit board. So we can measure equipment efficiency. Measurement of the input and the output power consumption on a UPS system will give an indication of the unit's operating efficiency at the current load. Older units could be operating as much as 10% less efficient than some of the newer models out there. Newer systems also have a better efficiency rating over a wider range of utilization. So, newer UPS systems operate much more efficiently at lower loads than their older predecessors. Existing cooling systems typically use constant speed fans. So these are likely, these systems are also likely capable of being retrofitted with variable speed fans or maybe ECM motors, which will match the fan speed to the cooling demand. And this will result in much higher efficiency operation as well. So proactively monitoring equipment operation, I mean, this is key. A preventative maintenance program is critical to ensure maximum uptime and efficiency. Factory certified technicians will follow manufacturers' maintenance guidelines and industry standards for best practices. They'll look for predictive signs of failure, such as capacitor leakage or high motor amperage, and also take battery inductance readings. The manufacturers will also periodically release technical bulletins regarding maintenance or recall issues and equipment end-of-life dates. So, beyond those dates, the manufacturers will no longer support the equipment. So this is a key thing to watch out for. But really, the key is monitoring. If we monitor the power, we can identify operational efficiency. This type of data should be recorded as part of the preventative maintenance program, and it should be trended over time so that we can provide an indication of when it may make sense to replace a piece of equipment. Older UPS systems, which operate at low loads, are typically very inefficient. So, continuing to operate those systems and maintain them can become very costly, especially if you compare it to replacement with a right-sized unit, which may also qualify for utility incentives. Another way to look at it is, you could replace the entire piece of equipment, or there are some potential upgrades available, especially with cooling systems. So some of the typical upgrades that are available are upgrades to the control systems, replacement of the fans with variable speed fans, and ultrasonic humidification is a good replacement for some of the older traditional styles of humidification and can save quite a bit of money. And so these types of projects, whether it be a complete replacement of the unit or an upgrade, are typically eligible for utility incentives, and the operating costs will be reduced, in which case the capital project may actually be largely funded by the utility. So how do we prioritize the equipment that needs to be replaced? I mean, efficiency is definitely a priority for, I think, most organizations and can have a dramatic effect on operational expenses. But reliability and site uptime are usually the prime concerns of a data center operator. So really the question becomes, which components of the infrastructure would have the greatest impact on the data center in the event of a failure? So, with preventative maintenance, most of these failures are predictable, and it's predictable through the analysis of component life expectancy and through data that's collected during the preventative maintenance program. Identifying older equipment that introduce unacceptable risks to your operation is likely going to be your top priority, but in this case, the improvement in operational efficiency when you upgrade or replace a piece of equipment becomes a great side benefit. So, as we stated, the significant improvements in efficiency can be realized through upgrade or replacement. The project cost is likely going to be less expensive if you compare it to the cost to maintain the older equipment, through repair and replacement of parts, and to continue to operate that equipment at poor efficiency ratings. So the cost analysis becomes, even more favorable if there are utility energy efficiency incentives out there that you can take advantage of. So I think that pretty much wraps up my piece of it. Move on to.
Thank you, Jim. We'll turn our attention to one of our presenters from the utilities. We'll start with Amelia from Lockheed Martin Con Edison.
Thanks, John. This is Amelia Axtell. So the three main takeaways I want you to get from our presentation is, one, we are here. Two, incentives are available for data centers and data center cooling. And three, speak to us as soon as possible when you have a data center project come up before work has started. Our program does not offer retroactive incentives, so it's really important for us to get involved as soon as possible when work is being done. So our program operates in the New York City service territory, which is the 5 boroughs and Westchester. So if it's something in New York State or elsewhere, we would refer you to another data center program. So we have two types of incentives that we offer. One is for the funding of energy efficiency studies, and that would offset the cost by 50% to do a study on the data center to identify energy efficiency opportunities. And then the second one is actual energy efficiency upgrades inside of the data center. And as you can see below, I've listed examples of the types of energy efficiency measures that we offer incentives for, including server virtualization and consolidation, storage optimization, PC power management, UPS, crack replacements, and then rising temperature set points and airflow optimization. Next slide, please. So in order to be eligible for our program, you need to be paying the system benefits charge on your Con Edison bill, and that's something that you can easily check on page 2 of your bill, and it will say SBC RPS, and that means you're eligible to participate in the program. The incentive that we calculate is based on the first year estimated energy savings of the project. So what we do is we take the post-installation kWh usage, or the projected post-installation kWh usage, subtract that by the pre-installation kWh usage, and then we multiply that by the incentive rate. And our incentive rate currently is 16 cents per kWh, so the incentive would be 16 cents times whatever the projected energy savings would be for the first year. And this is a rebate, so we generally cut the check after the work has been done and we've inspected it to make sure it's been completed. Just some kind of other highlights of our program. It's a very simple application and review process. We don't require any measurement and verification, and we also have a single point of contact for the data center program. That's me. So if you have any questions or any projects coming up, you can always contact me and let me know, and we can start the process together. And we also only cut the check to the person on the Con Edison account. So we unfortunately can't send it to a third party. We have to send it to somebody on the Con Edison account. Next slide, please. So here's just a couple of examples of case studies that we've done and successful projects that have come through our program. So the first one, we were able to convert data center Lieberts to dry coolers at a hospital university, and they received about $26,000 from us for doing that, and they reduced their utility bills by about $66,000, and it paid back within a year. So that was a very successful project. Another one was at a large office building in near Columbus Circle, and cooling containment measures were put into place in the data center, and that was able to receive an incentive for about $20,000, and that paid back in a little over a year. And then the final one is another office building in Manhattan. They installed an EMS system into the data center cooling system, and that resulted in about $150,000. This is a very, very large project. Resulted in about $150,000 in annual utility bill savings, and that got about a $110,000 incentive. The project cost, the project incentive caps are around $250,000 for data center projects. We do have a new program out that offers additional incentives on top of that if it is a large demand reduction project above 50 kW in demand, and we'll actually offer an additional $1,250 for every kW reduced on top of the 16 cents that we're currently offering. That has to be completed, installed, and operational by June 1st, 2016. That's called the Demand Management Program. So that's an additional incentive in addition to what we currently offer. So I just wanted to let you guys know about that as well. And that's about it for me.
Great. Thanks, Amelia. I appreciate that. Fran, we'll turn it over to you. Fran at National Grid.
Hello. Well, I'll share a little bit about what National Grid has to offer here. I'm not going to go right to the slides immediately. I'm going to cover some other information here. Our program covers new and retrofit efficiency opportunities, so you could be building a new data center or building out a new section of a data center, and we have incentives for that as well as the retrofit. Our incentives predominantly are offered for HVAC improvements, UPS improvements, and changes of DC rectifiers, which are popular in the communication sector. Right now, we do not have any opportunities for IT savings, either IT equipment, servers, or server virtualization, items like that. But we've looked at over 100 projects over the past 4 years since we started having a dedicated computer room and data center offering. And we work in rooms large and small, rooms that are much smaller than you would consider a data center. We can work in smaller computer rooms are fine as well. It's about the equipment and not the size of the room that matter to us. And it's not just about making things more efficient. Most often what we're able to do is to help the rooms get more uniform cooling, deal with hot spots, and deal with equipment that's aging or has sometimes has issues with its operation or not meeting the requirements of the project. So it doesn't have to be something you start because efficiency is on your mind. There can be other driving forces, and we can still help you because the same things that you would do to correct these overheating and aging equipment problems will save energy, and that's ultimately what we're after. The scope of our projects, we worked on projects from replacing a single HVAC unit up to $1 million airflow management projects. So there's quite a range that we cover, and in terms of incentives, we've offered incentives as much as $1 million for given projects over the years. So there's that's $1 million for a single project. So there could be some potentially large incentives in your future if you get interested in participating in our program. The biggest savings are going to come from projects that involve free cooling. That's cooling without compressors. And in the northern climates where we operate, National Grid operates in Massachusetts, Rhode Island, and upstate New York, there's plenty of hours of the year where it's possible to cool a computer room without running compressors. And also importantly, there are systems for the computer rooms where you can do cooling without compressors without bringing in outside air to do it. It can be done mechanically, and that can be an issue for some data center operators. They don't want outside air coming in to the space, but that's not a problem. There's still opportunities. We've also had projects where there's been tremendous savings from putting in a free cooling system that's also allowed us to work with the data center operators to upgrade controls. In one case recently, we worked with a data center where they were able to put controls on all their computer and air conditioning units that allowed operators to dial in and check on the equipment from home and be able to include that cost in part of the project cost and help them offset the cost of getting that additional those additional features as well. So we can, in the process of making things more efficient, we can often assist with making facilities more reliable as well. We'd love to get out there and talk to you about what your needs are and show you how we might help you. We would give a free initial evaluation for either some new equipment you're purchasing or just walking through your existing facility, and we would partner with EEC for that if that's your desire to help on the pricing and help on finding the equipment that they would know to be most satisfactory for you in terms of the manufacturer and the way it operates. Our incentives are a little bit different from Con Ed's. On the quick payback measures, you would get a little less money from us, but on the longer payback measures, there's potential to get an even greater incentive. Basically, we pay an incentive proportional to the savings. We cover up to 50% of the cost of the measure, but we limit the amount that we pay to bringing the project down to a 2-year payback. So if you have a project that's shorter than 2 years, you may not be eligible for an incentive. There is some flexibility in larger projects as far as these incentives go, and also some flexibility when you combine multiple projects. But at the same time, incentives of $500,000 more for a customer data center project is not out of the question. So I'll go to a few of the examples here, like the one on the slide here is a project we looked at for one of our customers. They had existing traditional computer and air conditioning units that did not have any type of economizer operation. There's a new unit from Liebert called the DSE unit that provides economizer cooling, that's cooling without the compressors operating in the winter without bringing in outside air. And the project cost was going to come in just over $250,000. We would be offering an incentive of about $118,000 for that project. The payback after incentives would be 3.7 years, which may not be attractive as an energy payback on its own as a motivator, but this company's equipment was getting a little bit older, and they said, gee, you know, if we can get a nice break on the cost and save some energy, we'll replace this 10, 12-year-old unit a little bit sooner. Next slide. Here's another project we worked in where the customer was replacing equipment that was at the end of life already. we were able to provide an incentive to get them to buy a more efficient piece of equipment, one that had a glycol-free heat exchanger, which allowed us to use free cooling. And the extra cost to buy the more efficient model was $91,000, and we were able to pay an incentive of $47,000 to bring it back to a payback of 2 years for the customer, which they found quite attractive. And next slide. And here's another situation which is not uncommon. We went into a facility and they had a chilled water cooling system. We discovered that they had a free cooling system, but it was not functional. It needed to be repaired and put back into service. There it was about just under $50,000 project that saved $38,000 a year. Now there's a project that has a simple payback of less than 2 years without any incentive, so there might not be an incentive for this project, but it would be certainly something that would be well worth pursuing by this owner. We could help them with the engineering and understanding the issues they have with it. And then I have one last example. Here's a situation common to communications facilities. They have DC rectifiers. These units were less than 15 years old, but they were still getting long in the tooth toward the end of their life. The customer had some interest in potentially replacing them. It's going to cost them $38,000 to replace these rectifiers. Our incentive was only $12,000, which brought it down to only an 8-year payback, which is, again, not a stellar payback, but if it's for something that they were considering doing fairly soon anyways, I think it was certainly helpful to have that cash input from the utility company to assist with the project. These rectifier projects, I find the prices all over the place in terms of payback depending upon the age and circumstances. I've seen projects that have much better than economics in this, so we would want to look at your particular project and hopefully find you do even better. And that's it for my presentation.
I think you had a couple more, Fran, that you wanted to go through.
No, just say, there's no cost for us to look at any opportunity at your facility. So just come in. We'll be glad to look at the facility, walk through with you or with EEC, and just see what the opportunities are for you. We have experts in this, and say we've looked at over 100 projects. We have one other thing that you might be interested in, that we offer a free service for our larger data center operators. If you have large numbers of servers in your facilities, we can do a free thermal mapping of your facility to determine where hotspots are, which might help you convince management that you need action to correct these, and the types of services that EEC and National Grid would provide would be appropriate for helping you save energy while reducing these hotspots.
All right. Great. Thanks, Fran. Appreciate that. We'll turn over to Patrick now at NSTAR, and we'll hear from him and the programs at NSTAR.
Sorry, left it on mute. Hi, this is Patrick. I'm trying to keep up with my Red Sox on the West Coast. I'm a little slow on the uptake here this morning. Got crushed again. Anyway, so NSTAR, we're an electric and gas utility in Greater Boston. We're now part of Northeast Utilities. So our franchise is now Connecticut, Eastern Mass, and parts of New Hampshire. More information on our website. So I thought I'd talk about my first slide here, showing some of the benefits of working through our programs, and I think these benefits are the same for most programs. So the first and foremost is obviously our financial incentives. So we seek to help the project economics on these expensive capital projects with our financial incentives. The other value that we deliver into this equation, though, is also validation. So we all of the utilities and service providers, we all have a stable of energy engineers, and all these guys do is look at energy projects and verify savings calculations from firms like Electronic Environments. So so the benefit to our customer there is that now you've got a second set of very talented eyeballs looking at these calcs and verifying the projected energy savings. Another benefit is, the customers that go through our programs, you're more engaged with us, and we like to think that that's kind of a benefit to you. If you're more closely engaged with us, you're more apt to reach out to us on upcoming projects and hopefully incorporate us into your long-term planning project. So that's benefit to the customers, some benefits to the utilities for NSTAR. A lot of folks who are new to our programs ask, well, why do you work with customers to reduce the product that drives revenues? Well, we receive performance incentives through our rate base. So our company has financial incentives to deliver savings. So that's one benefit. And we deliver cost-effective energy savings. So I just kind of put that point in there to highlight that the project has to be attractive, it has to be viable, and we do screen projects to make sure that they're cost-effective. In the last bullet, the last benefit, we survey the heck out of our customers through J.D. Power and other avenues, and we note a dramatic lift in J.D. Power scores from customers that go through and actually implement projects with us. And that's very important in the current regulatory environment in New England. So that's very valuable to us. So next slide. So again, what's some of the value that we deliver? I alluded to one of it earlier, engineering expertise. We've got a group of seasoned professionals. At NSTAR alone, we've got, I think it's six now, energy engineers, and focus on things like lighting or cry unit efficiencies, plate frame heat exchangers, things like that. We also offer benchmarking tools. If you're in the city of Boston, we now have a specialized tool to help you comply with the new BERDO requirement. We can also help you with Energy Star as well. We also have some fantastic partnerships with the local kind of energy efficiency community. So there's been a real niche developed over the past 10, 15 years where we're seeing engineering firms specialize almost exclusively on energy efficiency, and we're real tight with them. And also very tight with the vendors, as we call them, companies that get in and implement lighting projects and install drives on motors. So if you need, if you're outside of our territory looking at a project in our territory and you need referrals, guys like Fran and myself can certainly help. And the last bullet, again, one of the most obvious value add is our financial incentives. So we understand that implementing energy efficient capital projects is relatively expensive, and our financial incentives are meant to try to bridge that financial gap. Here's a real simple example of a project I did last year with a colo site here in Greater Boston. So this account of mine undertook a great project to retrofit 35 CRA fan motors with VFDs. Their project cost was about $175,000. Our incentive, we put forth $85,000, and that does not include some engineering support that we provided on the front end on our dime. Projected annual savings of the project was about $90,000 per year. So this, my final set of bullets here try to show the value of our program. So the customer could have done the project and not called us, and he still had a relatively nice project there, a 2-year simple payback. But with our financial incentive, the project became about a 1-year simple payback. So that became a real no-brainer, as it were. So how does it work? If you're kind of new to the energy efficiency game, all the utilities offer programs in a few different avenues. The first is what we call new construction, and that could be a new ground-up co-location site, or it could be you're installing a new centrifugal chiller on site. A large capital project like that we also call new construction. The next bullet there, retrofit, which most of you are probably familiar with. So the most obvious example is a lighting retrofit. If you've got T8 lighting and you're ready to take the plunge and convert to LED, a project like that would go through the retrofit program. And the last bullet is facility assessments. So we understand that data centers are very complex places, and assessing them is quite involved. It's not as easy as doing a walkthrough of a common area and looking at lighting. It's very complex and usually requires specialized engineering resources. And again, that's where we can help. We can bring in folks to help with that, or if you have a preferred firm that you like to work with, we can oftentimes share some of those costs with you. So I'm just generally trying to point out the different programs that we offer, but they're very complicated. If you only do 2 or 3 projects a year, we don't expect you to be expert at these. That's why guys like Fran and myself and Amelia, and ladies like Amelia are employed to help you guys through these programs. So I think that might be my last slide.
Great.
And I'll transition back to John.
Excellent. Thanks, Patrick. Thank you, too, for presenting Amelia, Fran, and Jim. This will conclude our webinar for today. Hope it was helpful, hope it was valuable. We covered some best practices from the electronic environment side and things that we're seeing in the field to help you gauge that critical point to potentially upgrade or replace some equipment or even get some extra life out of it. And then with our guest speakers today, discussing different utility programs and all designed to help improve the reliability and the efficiency of your site. If you have any questions, of course, you can reach out to Electronic Environments, email, web, and blog for more information. We work with these utility partners who are our presenters today, designed to help you address the issues that were presented today, and look forward to doing that with you in the future. Thank you very much for attending today, and I appreciate everyone's time.